Okay guys, welcome to day 32 of solving an integral for 1000 days, and today we have a fairly special integral for Neve because he's been asking for this for a long time. So today we're going to integrate e raised to minus x squared, also known as the Gaussian integral. Gaussian integral. So this is what we're going to do for our question today. So how would you solve this? Well, to solve this, you would just need to use this formula. 1 second. April Fools, we're not solving the Gaussian today. Are you stupid? I am not smart enough for this. Okay, so we're not solving the Gaussian today, but we are solving something new. So today we're going to start partial fractions, and our integral for today is 1 by x squared minus 1 dx. So what exactly is partial fractions? So you do partial fractions when you have a fraction which is a product. So now this integral can be rewritten as 1 by x minus 1 into x plus 1, because that is the property. A square minus b squared is a minus b into a plus b. So after this is basically a theorem or something, but if you write this 1 by x minus 1 into x plus 1, this is equal to a by x minus 1 plus b by x plus 1. So if we had another fraction over here, that would become plus c by x minus 1. Because when you cross multiply this, you basically get 1 is equal to a x plus 1 plus b x minus 1 by x minus 1 x plus 1, which is exactly what we have over here. So you can see that the denominator on both of these sides cancels out, and finally we're left with 1 is equal to ax plus a plus bx minus b when you open the bracket, and then we get 1 is equal to x a plus b plus a minus b. Now here you can see two things. We can see something with x and the coefficient is a plus b, and we can see that a minus b is the constant. Now there's no x term, so that means our a plus b for LHS is equal to RHS would be equal to 0, which means our a is equal to minus b. Okay, a is equal to minus b. That is our first thing. And here we can see that a minus b is equal to 1. So a minus b is equal to 1. And here we know that minus b, this part, is equal to a. So here we get a plus a is equal to 1. That means 2a is equal to 1, which means a is equal to 1 by 2. And we know that our b is equal to minus of a if we take the minus to the other side. So our a becomes 1 by 2 and b becomes minus 1 by 2. So this is how we get our constant term from the partial fractions. Now what do we do from here? I'm going to have to erase this so it's easier. So now that we've gotten our a and b, we can see that we rewrote our integral as this. So we just write this with the constants. So our integral is split up into the integral of 1 by 2, it's a constant so you can take it outside, by 1 by x minus 1 dx plus b, which is our minus 1 by 2. So this plus becomes minus 1 by 2 integral of 1 by x plus 1 dx. So this both are just simple log integrals. So our final answer becomes 1 by 2 ln of x minus 1 minus 1 by 2 ln of x plus 1 plus or minus c. Now you can leave the answer in this, but the smarter way to finish off the question is to use log properties. So if we take 1 by 2, we can take it as common, and then ln a minus ln b is just ln a by b. So this becomes ln x minus 1 by x plus 1 plus or minus c. So this becomes our final answer through partial fractions. So we had our integral in the starting, which was this, and then we used partial fractions to remove the denominator and then get an equation here where we could get our a and b terms. We got our a and b terms, and then we just substituted it in this over here, and then we solved it, and then through Ln rules we got this. So that was the integral for today. It is April 1st and it is day 32, and we've started partial fractions. And I hope you guys like my tiara because I really like how it makes me look. So that was the integral for today, partial fractions. We tried solving the Gaussian, but it is April Fool's. So hopefully Neve found that funny. And yes, that's pretty much the question for today. And for around 2 to 4 weeks, we're going to do partial fractions. So question for today, and I'll see you tomorrow. Bye bye.